Seeking English, S.A.T. Workbook, page 469. Problem 1, no calculator, and I would not know how to use a calculator in this problem. It says, how many ordered pairs, that's an x and a y, satisfy the system of equations shown above? And you get these two equations. Answers are 0, 1, 2, and infinitely many. Now, hopefully you already know this. In a system of equations, the solution space or solution set provided by the first equation is not increased by the second equation or vice versa, no matter what order you put them in. Okay, the aggregate solution space or solution set will be equal to or smaller than either of those equations. So first equation in this case, y equals 3x minus 9, is a straight line. Hopefully you recognize that as a straight line. It is in slope-intercept form. The slope is 3. The intercept point is minus 9. Okay, so don't worry too much. If you want to visualize it on a graph, great. But I know I'm always saying that it usually takes longer to decide not to draw something than it takes to draw it. Okay, in this case, I hate to offer you an exception, but I do have to offer you an exception. If you understand this problem structurally, drawing it is probably not going to give you any additional information. In this case, drawing it is probably your last resort before just sort of eyeballing it. Okay, if you understand it conceptually, by the time you take the test, your judgment should be good enough to realize I don't need to draw that. I'm not going to draw it unless something goes really wrong with it. And the way this problem is structured is that if you actually understand this problem correctly, an extremely similar problem on the test, you should be able to solve it with very little work in very little time. It just confuses students because they're not sure where to start with it. So I'm going to show you where to start. You have these two equations. If you did graph them, they would intersect at 0 points, 1 points, 2 points, or an infinite number of points. How can we reduce this number of possible answers from 4 answers to something smaller? Infinitely many is a problem because the second line is actually a parabola. Okay, so if you visualize how many ways a parabola and a straight line can fall on a graph, it's possible they would never touch each other. Okay, that's possible. There are a bunch of ways but they'll have something in common. Okay, now the answer number 1. Many textbooks show a parabola intersecting with a line such as an axis only at the vertex. That's very common to see. So that's a plausible configuration. Although vertex is not the only way. Is not the only place in which a straight line could be tangent or even intersect a parabola. It's not the only place. Okay, so that's a possibility. 2 is another obvious possibility. Many textbook problems show an axis, such as the x-axis, intersecting a parabola that has a vertex lower than the x-axis. Or you've probably seen it by now. If you haven't, take a look. Okay. 2 solutions is plausible, 1 solution is plausible, 0 solutions is plausible. But I defy you, and if you can do this, I'd be delighted to see it. I defy you to come up with a straight line and a parabola that have an infinite number of solutions at any normal level of mathematical rigor. So D is pretty much off the list. Okay, and if you think D is a viable answer, don't feel insulted, don't feel threatened. Please tell me about it in the comments section, and we will go over it. Okay, not because I'm likely to agree with you, but because understanding your argument is important to me. It is important, and I am not infallible. Okay, in the meantime, yeah, D is off the list. So what do we want to do with this? The way, if you can get x or y out of the system of equations, that makes it a lot easier to see what you're doing. Really? Yes. Is that fair? Yeah, it's fair like this. I don't have to plug in an integer for y. Okay, that kind of wouldn't, I don't want to say it's unfair, that's not the correct term, but it's a similar idea. You don't want to plug in an integer for y because you can't, because you're supposed to have more values than that, and you potentially have more of that. Okay, hopefully you see my point. You can plug this in for y because for something to be a solution to the system of equations, okay, we should be able to say that if something is this y, it is also that y. Okay? If you don't see what I just did there, or you don't understand what I just said, slow it down, watch it again. I need you to see this point. for something to be a solution to a system of these equations, this y and that y have to be the same. And because they are the same, if they are each equal to the thing on the other side of the equation, okay, then this has to be equal to that for these two y's to be the same. That means I can plug in this 3x minus 9 for y to try to get this down to a more obvious quadratic. Can that be done? Well, let's see. It's been a while since I've worked on this problem. Okay, so I'm gonna multiply this through to try to move that over. Okay, hopefully you know where I'm going with this. It becomes 2x squared. Okay, I'm going to show both middle terms just so you can see everything that I'm doing. It becomes plus 4x, becomes minus 5x, okay, and minus 10. Okay, so I am going to condense these two middle terms. I just wanted you to see what they are so that you're not doubting what I'm doing. It becomes minus x minus 10. Okay. From there, what I want over here is a 0. I want a 0, okay? I do that by subtracting 3x from both sides. I get minus 4x there, and that is gone. And I can add 9 to both sides, and I get a minus 1 here. Okay? From there, it is a standard quadratic. Okay? So you should be suspecting that there are two solutions, meaning that in order to satisfy both this and this, okay, you would have two things that you could plug in for x to produce y as a 0. Okay? Okay? So what if it's some other y? Well, if it's some other y, no good. No good, because I know that this y and this y have to be the same, and that means that this y has to be this expression for x, okay, as equal to this other expression for x, in which x can be two different things. I know it's complicated. It's not that complicated. You'll see. Okay, so here, because of this square function, okay, because of this square function, we expect probably two values for x at one value for y. So this whole thing here is reducible to this. These two equations are equivalent to this one equation. So it's no longer a system of equations. It's actually now just one equation. Okay, how many solutions are there between these? Only what fits here. Only what fits here. So what is it? I'm just going to go through the routine with you. Okay. But I'm not going to do it all the way because you'll be wasting your time doing it all the way on the test. That's over to it. I know it's a bit of a jumble here. A bit of a jumble. Okay, so A is 2. That means this becomes 4. Okay, and to save time, I'm going to turn that into minus 8. That's C is a minus 1. I go to C before I go to B. That's just me. Okay, so that becomes plus 8. Okay, B squared. Okay, B becomes 4. This becomes 16. Okay, so now it is all integers. From there, you can split this, put it over its own 4, just for good measure, and you've got some, it's 24 here. Okay, but teacher, that's going to be really complicated. It's complicated enough that if you want to calculate it all the way out, it's going to take you a few extra seconds. You don't want to do that on the test, because once you see what the answer is, you're done. Don't go beyond the answer, looking for some other answer that they have not asked for. Okay, this is going to be equivalent to 1, but it kind of doesn't matter what it is. It could be anything over here. It could be pi. It doesn't matter. This plus or minus is what you're interested in, because this is a real number. Okay, you can reduce it if you want, but what you need to know is it's a real positive number that has been put into positive and negative in combination with this one. So the plus and the minus provide the two solutions that you're looking for. So the answer is C. And if you're not clear on this, tell me in the comments section. I have to see what the distraction is. Thanks.